everyone, we're going to identify and graph the polar equation r equals 2 minus 2 cosine of theta. This is a cardioid, and I will show you the form of the cardioids in just a few moments. For now, what we want to do is test for symmetry, so it makes it easier to graph. So we're going to check condition 1, condition 2, and condition 3. So for condition 1, we take our r equals 2 minus 2 cosine of theta and substitute theta with negative theta. So that would be 2 minus 2 cosine of negative theta. Now since cosine's an even function, we can just make that positive. So we have 2 minus 2 cosine of theta. Now since these two equal, then it does mean it's symmetric with respect to the polar axis. So this checks off. Now we want to check symmetry with respect to the line theta equals pi divided by 2, which is actually symmetric to the y-axis. So to do that, we're going to replace our theta with pi minus theta. So I'm going to write this as r equals 2 minus 2 cosine of, now my theta is going to turn to be pi minus theta. This is your sum and difference formula given here. So I can write this as r equals, let's just write equals so I can save some room here, equals 2 minus 2, and then we're going to write expand it using the right hand side there. So it's going to be cosine of pi times cosine of theta plus sine of pi times sine of theta. All right, sine of pi is just 0, so that goes away. Cosine of pi is negative 1. So basically what we have is r equals 2 minus 2. This is negative 1, so this is going to be negative cosine of theta. This gives me r equals 2 plus 2 cosine of theta, which does not equal r equal 2 minus 2 cosine of theta. That means condition 2 here fails. Our graph is not going to be symmetric with respect to the line theta equals pi divided by 2. Now let's check for symmetry with respect to the origin or the pole. So that means we're just going to substitute our r with negative r. And if you do that, and we don't get back the original equation, mainly because this is not squared. So it's not, this test fails. This is the cardioid form. We have cosine here, and our a in our case is 2. So this is a typical graph. It looks like a heart shape. Also, with this condition 3 here, the only time it's going to be symmetric to the pole is if you have a r squared. So basically, this would be the graph for that. Let's go ahead and graph this now. Since it is symmetric to our polar axis, condition 1 here, we're going to choose our values from 0 to pi. So our angle is going to be in between 0 to pi. All right, let me scoot this up. We have theta, and we're going to go 0 to pi. All right, so we have 0, pi divided by 6, pi divided by 3, pi divided by 2, 2 pi divided by 3, 5 pi divided by 6, and pi. And our equation is 2 minus 2 cosine of theta. Now substituting everything in, at angle r theta equals 0, we're going to get 0. At pi over 6, we're going to get 2 minus square root of 3. That's approximately 0.3. At pi divided by 3, we get 1. And then pi divided by 2, we get 2. 3. This one's going to be 2 plus square root of 3, which is approximately 3.7. And at pi, we're going to get 4. All right, and then we know it's symmetric to the polar axis. So let's go ahead and plot some points. We're starting at 0, 0, which is there. Now pi divided by 6, we're at very close to 0. So I'll just put a little dot there. All right, at pi divided by 3, we're at 1, which is right there. At pi divided by 2, we're at 2. So this is right up there. At 2 pi divided by 3, we're at 3. At 5 pi divided by 6, we're at 3.7, which is close to 4. So I'll put it there. And at pi, this is pi, we're at 4. So it starts through here and goes around. And there we go. Now we know it's symmetric to the polar axis here. Put this in green. So from here we can just kind of make it symmetric and go to 11 pi over 6 and put that at very close to 0. And then at 5 pi divided by 3, that's going to be at 1. At 3 pi divided by 2, that's going to be here down at negative 2. This was at 1. Let me put this back to 1. Then we're at 2. And at 4 pi divided by 3, it's symmetric with 2 pi divided by 3. And that was at 1, 2, 3. So we got 1, 2, 3. And then at 7 pi divided by 6, that was very close to 4. 2, 3, 4. So very close. And then you just kind of swing this around. And there's your heart-shaped cardioid. That's it. Thank you. Have a nice day. Bye-bye.